Nearly every modern graphical interface is implemented using some form of user interface toolkit. These toolkits provide libraries of widgets and associated frameworks that reduce the time, effort, and amount of code required to implement interfaces. Although such toolkits provide many important advantages, they sometimes create significant challenges for research and practice. For example, the human-computer interaction research community has developed a variety of target-aware pointing techniques. Grossman and Balakrishnan's bubble cursor is a technique that dynamically sizes the cursor so that it always captures the nearest target. Warden et al.'s sticky icons are another target-aware pointing technique, reducing mouse gain when the cursor is inside a target to make it easier to successfully click that target. Despite the potential promise of these and other interaction techniques, they are not commonly available in widely used applications. One important reason for this is that they are not supported by existing toolkits. We are exploring a new approach to adding advanced behaviors to existing interfaces that is independent of the toolkits used to implement those interfaces. Our approach is based on one thing all user interface toolkits have in common, that they ultimately paint pixels to a display. Specifically, we copy the pixels from a source window. We then interpret these pixels using Prefab. Using these interpretations, we add enhancements like the bubble cursor and show them in a new target window. Input is then mapped to the source window. All of the demonstrations we now present are implemented entirely based on the actual pixels of the interfaces. Here is our implementation of Grossman and Balakrishnan's bubble cursor, using Prefab to identify targets within a dialog box presented by Mozilla Firefox running on Microsoft Windows Vista. And here is the same target detection being used to implement sticky icons. Now we have used remote desktop software to connect to a Macintosh OS X machine. All of our pixel processing is still running on the Windows Vista machine, and our bubble cursor is targeting the Macintosh widgets. Note this is the same code we were using with the Windows version. And here is our Windows Vista machine adding sticky icon functionality to the same Macintosh dialog. These types of platform-agnostic enhancements are possible because Prefab is based entirely on the pixels of the interface. And Prefab is not limited to recognizing only standard operating system widgets. Here we show our bubble cursor using Prefab to detect the buttons on a YouTube movie player. Some interaction behaviors need to be aware when a widget changes state. For example, Bowdish et al.'s Phosphor uses graphical transitions to illustrate interface changes. Here you can see a flash demo by Bowdish that animates checkboxes and sliders in green when their state is updated. Prefab also notices transitions in a widget's appearance in real time, enabling applications like Phosphor to be implemented over existing applications. Here you can see Phosphor running on a Windows Media Player dialog box running in Windows Vista. Like before, we can use the same code to apply Phosphor effects to an iTunes dialog box running on Mac OS X. Sometimes researchers would also like to automatically modify elements of an existing interface. For example, in their side views research, Terry and Minot showed parameter spectrums can support effective exploration of multi-parameter spaces. Using GIMP, they preview the effects of various image filters. Unfortunately, this work was restricted to GIMP because its code is publicly available. Using Prefab, it is possible to generate a parameter spectrum preview without modifying GIMP's code. To generate the previews, Prefab automatically varies the slider values on a GIMP filter dialog. After the slider values are varied, Prefab copies the image from the preview area of the dialog. We can also use this implementation to generate a parameter spectrum preview for Adobe Photoshop. This particular filter takes a few seconds to process, so Prefab waits until the status of the progress bar at the bottom left of the window has completed. The difficulty of implementing new interaction techniques in new and existing applications and toolkits is currently limiting the progress and impact of human-computer interaction research. We have presented Prefab, a system that enables a wide variety of applications based on pixel-based reverse engineering of interfaces, built upon the insight of separating the modeling of widget layout from the recognition of widget appearance.